In this video, we're talking about one of the rules that we always have to follow when we're solving algebraic equations, and that's called balancing the equation or keeping the equation balanced. And all we mean when we say that we want to keep an equation balanced is that we always want to do the same thing to both sides of the equation. So let's look at a very simple equation here. For example, x is equal to x. We can see right away, we know intuitively, that this equation is perfectly balanced. Of course x is equal to x, they're the same thing. So both sides of the equation are balanced. But we can start manipulating this equation if we want to by, for example, multiplying both sides by 5. If we multiply the left-hand side by 5, this equation is now out of balance unless we also multiply the right-hand side by 5. Now the equation is balanced again because we've multiplied both sides by 5. So in other words, whatever you do to one side of the equation, you always have to do to the other side. So if now all of a sudden we want to divide the left-hand side by 2, so we want to divide this by 2, we also have to divide the right-hand side by 2 to keep the equation balanced. And if we get a little fancier and we want to, for example, take the square root of the left-hand side, we also have to take the square root of the right-hand side in order to keep the equation balanced. So just remember that the idea is whatever you do to one side, you also have to do to the other side. It's like keeping it fair. So now if we look at this example over here on the left, we have the equation x plus 5 is equal to 2. We want to solve this equation for x, keeping this principle that we just learned in mind. If we want to solve this equation for x, we've got x over here on the left-hand side. We need to get it by itself. And the only way that we can get it by itself is if we subtract 5 from the left-hand side. We got to get rid of this positive 5 here. And the way that we get rid of a positive 5 is by subtracting 5 from the left-hand side. So we can put it right underneath here and say minus 5. But if we're going to subtract 5 from the left-hand side, we also have to subtract 5 from the right-hand side if we're going to keep the equation balanced. So we'll go ahead and put a minus 5 over here. And then if we just add these together, if we say x plus 5 minus 5, we know we're going to get our positive 5 and our negative 5 to cancel, and we're just left with x over here on the left-hand side. So we have x on the left-hand side by itself like we wanted to because we wanted to solve for it. And on the right-hand side, we have 2 plus a negative 5, or just 2 minus 5. 2 minus 5 gives us a negative 3, and we can see that x is equal to negative 3. Now, if we want to double check ourselves and show that balancing works, what we can do is plug our solution, x equals negative 3, back into the original equation that we were given. So we had x plus 5 is equal to 2. If we plug negative 3 in for x, we get negative 3 plus 5 is equal to 2. Over here on the left, we can do this simple arithmetic. We get negative 3 plus 5 is 2. We can say 5 minus 3 is 2. Either way, we get 2 is equal to 2. And because this checks out here, we know that we found the correct solution for x. If, on the other hand, we had not kept the equation balanced, if we had just subtracted 5 from the left-hand side only, if we had said x plus 5 equals 2, our original equation, and we had subtracted 5 from the left-hand side, we would have gotten our 5 and our negative 5 to cancel, and we would have been left with just x is equal to 2, which we know would have been an incorrect solution, because if we plugged it back into our original equation, we would have gotten 2 plus 5 is equal to 2, 7 is equal to 2, and of course, that's not true. So we know that x equals 2 is not a correct solution, and the reason it's not correct is because we didn't keep our equation balanced. We only subtracted 5 from the left-hand side. So whatever you do to one side, you have to do to both in order to come up with the correct solution for the variable in our equation. So let's look at a problem that's slightly more complicated. In this problem, we want to solve for x. We have x over here on the left-hand side, so we want to get it by itself. Well, the first thing we can do is subtract 1 from both sides. We have a positive 1 on the left. If we subtract 1 from both sides, we'll get rid of the positive 1 on the left-hand side. So we'll be left with 3x here, plus 1 minus 1. Those will cancel with each other. We get 10 minus 1 is just 9. So we have 3x is equal to 9. Now, in order to get x by itself, we need to divide by 3 to get this coefficient removed from the x. So if we divide the left side by 3, we also have to divide the right side by 3. And the result, we're going to get the 3's to cancel on the left, leaving us with just x. The result on the right-hand side, 9 divided by 3 is 3, so we get x is equal to 3, so that's our solution. And if we double check ourselves by plugging it back into our original equation, we get 3 times 3 when we plug in x equals 3 here, plus 1 is equal to 10. And if we solve this, we get 9 plus 1 is equal to 10, or just 10 is equal to 10. And because that checks out, we know we got the correct solution for x. So just remember, always keep your equations balanced. Whatever you do to one side, you have to do to the other.